Hello everyone, welcome to the ninth week of our coding lessons. Announcement, if you haven't done it yet, please go to the Google Classroom and finish the midterm exam. Some of you haven't turned it in. Thank you very much. So today, we're going to talk about binary language, decimal versus binary, binary to decimal, and we'll do an activity, more like homework in MakeApp. All right, challenge. Up to what number can you count using one hand? Pause the video and think about how many numbers you can count with one hand and come back once you have an answer. A lot of you might have said 5, right? 1, 2, 3, 4, 5. That makes sense. But through this lesson, hopefully everyone who's watching this video will learn how to count up to 31. Yeah, without cheating. So binary language. As you can see, you see a bunch of zeros and ones, and yes, that's binary. We might have covered it before, but today we're gonna go in a little bit more depth, okay? All right, think about videos, audios, or map, or any documents you have seen on your phone, your computer. Now, all those are written in zeros and ones, okay? All of them. It's fascinating, right? So all the files, all the data, picture data, audio data, video data, or text data, numerical data, all of them are written in binary code in computer and stored as binary code. Meaning, when we access them, we see them as videos, pictures, audio, text, numbers. But when it's stored, they're all stored in either zeros or ones, bunch of zeros and ones. Okay. Yeah. So binary, what is it? It's a language the computer uses. So like the name suggests, bi means two. So binary can have two values, either zero or one. Electronically, zero means off. Okay. One means on. Okay. So the reason why they use binary is because it's reliable. So pause the video to think about why. Maybe you can go to the next slide and then you can think about why it might be reliable, okay? So let's talk about the difference between decimal and binary. Everyone in this room hopefully is familiar with decimal system. Now you may not familiar with the name, the decimal system, but you know what it is, okay? So when I give you this number 109, right? Everyone should know that I'm talking about 109, right? So in decimal system, it's just normal, it's like normal number that we use, okay? Each placeholder can have 10 different values from 0 to 9, meaning in this, it can be 0 to 9, even though I wrote 9 as an example, it can be any number between 0 to 9, and even this position can have 0 to 9, here 0 to 9. And also each placeholder represent the power of 10, meaning the first position, it represents the 10 to the 0th power or ones. So we call this unit digit or ones digit. Now the second represents 10 to the first power, which is 10, meaning this is 10th digit. And this is 100th digit. So that means when you have 9 in the ones digit, we're talking about 9. But when you have 0 in 10th digit, that means we have 0 tenths. But when you have 1 in 100, that means we have 100. Therefore, we have 109. Okay? Now you might be thinking, hey, isn't that obvious? Yes, it is obvious. Yes. So there we go. Now let's go to binary system. Okay. So remember this, each placeholder can have up to have two values, okay? Either 0 or 1. It cannot be 2 or 3, it has to be 0 or 1. Each placeholder represents the power of 2, and we call this bit, okay? So we have how many placeholders? We have 1 placeholder, 2, 3, so we call this 3-bit, okay? Because there are 3 digits. Now we have the first digit, second, third. Notice that we start from 0, okay? So anyway, the first digit represents 2 to the 0 power, which means 1. The second one represents 2 to the first power, which is 2. And this third digit represents 2 to the second power, which is 4. So now, this means we have 1 ones, 0 twos, and we have 1 fours. Okay, so we have 1 here, 0 here, 4 here. So when you add them up, what do we get? We get 5. So number 5 is represented by 101 in binary system. Now, if you don't fully get that, I understand. We're going to do an example very soon. But let's think about why this is way more reliable than using decimal. And why can't we just use 5 instead of 101? And this is why. Now, you have seen the picture before, in two slides here. The way that computers store data is not like our brain. Okay, maybe it is in a way, but it's stored in something called transistors. Okay, all these little dots are transistors. Okay, and transistors can have either 0 or 1, but in reality, it cannot be flat 0 or 1. So what we have is we have low voltage versus high voltage, where high voltage is usually about 5 volts. Okay, so the reason why using binaries is useful is because the voltage in transistors may fluctuate. Okay, so for example, this low, this is supposed to be 0, but sometimes it can go up to maybe 1 volt. But computers, because it only uses binary system, that 1 voltage is also considered to be low. So that means even if it's 1 volt, it will consider that as 0 or off. Okay, so that's why binary is useful and reliable, because why? It ignores, or it's resilient to, electrical noise in the machine. Okay. Right. Anyway, moving on. Let's see how decimal system works. We have 42, right? So even though this is obvious, we want to go through this. Okay. So when we have 2 in this digit, this means 2 times 10 to the 0 power. Now remember, 10 to the 0 power is 1. So 2 times 1 is 2. Okay. Now when you have 4 in the 10th digit, that means 4 times 10 to the first power, which is 40. So we're just dissecting each digit in decimal system. And when we add them up, what do we get? Oh, I'm sorry. So that 0th digit represents the power here, exponent, and that first represents the first power. Okay, just keep that in mind. And when we add them up, we get 42. Okay, obvious, right? Now, another example, let's use a bigger number, maybe 314, right? So let's do the same thing, okay? We have 4 in the first place, 1 in the second place, and 3 in the third place, right? Notice that the exponents are always off by 1, okay? So 3 here means what? We have 300. When we have 1 in tens, that means we have 10. When we have 4 in ones, that means we have 4. Combine them, you have 314, okay? Now, this is obvious because everyone has learned this and everyone has been using it, okay? So let's use this in binary system, okay? So let's say we have binary system. We have 1, 2, 3, 4, 5, 6. This is a 6-bit binary, okay? Because there's 6 digits, right? 0th digit, first digit, second, third, fourth, fifth. There's 6 digits total, okay? So what if we have 1 0 in binary system? Now, this is not decimal system, so do not say this is 10, okay? It's not 10, okay? It's 1 0, right? Actually, I was supposed to use like 0 0 0 0 1 0, but it's okay. But anyway, let's talk about this, okay? So we said each placeholder represents what? 2 to the exponent, right? So this digit represents 2 to the 0 power. This digit represents 2 to the first power, okay? 2 to the 0 power is 1, 2 to the first power is 2, but we have what? 0 of 1, right? So notice the exponents again. Yeah, too much animation maybe, I'm sorry. But when we multiply this, what do we get? 0 times 1 is 0. 1 times 2 is 2. Okay? So does that mean 1, 0 is 20? No, you have to add them up. Okay? You have to add them up and we get 2. So in binary, 1, 0 means what? 2. Right? It's not 10. Do not read this as 10. Okay? This is a binary system. Now let's make these things more complicated. Okay? So let's say we have 0, 0, 1, 0, 1, 1. How can we convert this into binary decimal system? Because why? It's hard to understand for us. We understand decimal. Machines can understand binary. So we need to be able to convert one from the other. Okay, so let's do this. So remember that the 0th digit is 0 to the first power, 0 to the 0, 2 to the 0 power, which is 1. The first digit is 2 to the first power, which is 2, and so on. Do you see that as you go more towards left, the power of 2 is keep increasing. So you might want to remember 1, 2, 4, 8, 16, 32. Okay, you have seen these numbers because if you look at your mobile phones or computers, usually your memory and your storage, they go by power of 2s. Maybe 64 gigabytes, you have 128 gigabytes, maybe you have 256 gigabytes. It's not random numbers, it's a power of 2s, okay? But anyway, let's look at this. So when we have 1, that means it's on. When we have 0, it's off, okay? So let's do one by one. All right, so maybe the whole thing. So that 1 means what? It's on. This means on, off, right? So that means for the 1s, it's on, so you get 1. For the 2, it's on, so you get 2. For value of 4, it's 0, so it's off. So you don't get anything. For placement value of 8, or 2 to the third power, it's on, so you get value 8. And the rest are zeros, so you get 0. When we add them up, what do we get? Oops, I'm sorry. When we add them up, what do we get? We get 11. So that means what? 0, 0, 1, 0, 1, 1 is 11 in our decimal system. Now let's do another example. By the way, if you get stuck, please rewatch sections of the video, right? Because it does require some math, okay, and thinking. So let's do another example. Right? Example number 2. By the way, if you want to try on your own, pause the video and try it, okay? All right, now let's go over this. 0, 1, 0, sorry, 1, 1, 0, 0, 1, 0. This is still 6-bit binary number. Right? Just think of them as an on or off, okay? So on, off, on, off, right? So how many zeros do we, how many ones do we get? 0. How many twos we get? 2 and 1, right? So we get 2, 0, 0, 16, 32, right? So whenever it's on, you get that value, okay? Because the fifth digit or the sixth digit was on, you get 32. And because the fifth digit was on, right, you get 16, and so on, right? When you add them up, you get 50. So 50 equals 110010. It's weird, right? But the reason why they use this instead of just 50 is because this is more reliable, okay? Hopefully I covered that part. Practice problems. Convert the following binary numbers into decimal numbers. Pause the video, try this. By the way, these are a 5-bit number system, okay? Let's go. Welcome back. Let's go to the solution. These are the solutions. So for the first one, let's go through it fast, okay? We have the first digit, right? The 0th digit on. So that means 1 times 2 to the 0 power, which is 1. Now we have a 0th digit and the first digit on. So that means 2 to the first power is on. 2 to the 0 power is 1, is on. So 2 plus 1 is 3. So this is 3. And if you look at this one, the 0th digit is on, and the third digit is on. So 2 to the power of 3 and 2 to the 0 power of 0 is on. So you have 8 plus 1, which is 9. Now, what about 1, 1, 1, 1? Now, this is 31 because all of them are on. So it's like 16 is on, 8 is on, 4 is on, 2 is on, 1 is on, and 31 is the value. And guess what? That is how many numbers you can count with one hand. Let's read this. There are 10 kinds of people in this world, those who understand binary and those who don't. Hopefully you get this. This is not 10, right? This is 2 in binary, okay? So next time when we meet, we'll talk about alphabets in binary and binary puzzles. Decimal to binary, we might hold off onto we might hold this until like later in the future because it does require more math than today. But if you want to try it, feel free to try, okay? All right, now let's talk about Make app. All right, so open up your Make app and let's go to project. Now, once you're in project, let's go to, make sure you're in Make example and scroll through so you find this. You find bins for lazy person. Click this. Now, what I want you to do is I want you to try making this, okay? So it uses 2 sensors that we haven't used yet, okay? We're using, what is it? The ultrasonic sensor. Also, you're using the motor, okay? Now, even though this thing, it uses like extra materials, you do not have to do that if you don't want to. That's totally fine. So basically what this does, you can read through this later, but when something is near the sensor, it automatically moves the bin's lid up, okay? And then down later on. So if you want to make this into this, it's fine. Or you can make an automatic door if you want to. But eventually what we want to do is we want to be able to use ultrasonic wave sensor so that when there's a car coming in, it changes traffic light. But for now, I want you to do this example, follow along this and use the example code they give you, right? Play along with this, okay? So that it does what you want to do. So next time when we meet next week, I'll give you an assignment where you have to create ultrasonic sensor so that it modifies your traffic light. Okay. Hey, thank you everyone. So go to this, read through this. It's pretty easy. It's pretty easy to follow, but you have to be creative if you want to create something like this. Okay. But the mechanics behind it is very simple, okay? Try it, experiment, and have fun, okay? Thank you, everyone. I hope everyone has a nice week, and I'll see you next week. Bye-bye.